Welcome everyone. Let us move on to chapter 4 from module 1, big data analytics. In this particular chapter we have two sections, that is 4.1 and 4.2, in which we will be covering the first section over here, 4.1. And this 4.1 itself has 11 sub sections. Okay, so we'll tell first we'll talk about NoSQL. Okay, so the first thing, NoSQL, the full form we have to tell is that is not only SQL. Okay, it refers to a family of non-relational, open source, distributed, schema-less, cluster-friendly databases designed for modern web and big data applications. So in the definition itself, it has many key points which we can use to explain this database, that is NoSQL. Okay, so where it is used, the first section 4.1 talks about where it is used. So in the textbook this whole section is for only 9 pages. Okay, so this complete entire section is for 9 pages and it consists of diagrams as well in the middle, and 11 sections, subsections within 9 pages including diagrams. So each section has very tiny bit of explanation. Okay, so we'll talk about where it is used. It is used when we are delivering large enormous data, and we need fast and continuous. When the data is fast and continuous, we use in such places. Then also when the data is hard to store or analyze in normal RDBMS, then we move on to NoSQL. Okay. Then the second section, what is it? So there has to be a question mark over here. What is NoSQL? So it is non-relational. To understand what is non-relational, you have to understand like key value pair, document, columns, graph. So it can be anything. So it's not related to one type of data, multiple types. It is distributed in the sense what they are distributed across multiple cheap nodes. Okay, so we are not trying to make it expensive. We are trying to distribute in multiple cheap nodes. Then usually do not provide full asset properties, but it follows CAP theorem: consistency, availability, and partition tolerant. Schema flexible, so it doesn't require a fixed schema, no strict table design or anything required. We have types of NoSQL. Okay, so this very simple small 4 types, and this same thing repeats in section 4.1.7. What is the use in industry? What is the use of NoSQL in industry? So we have the first is key value store. So see, there is a value. Every value is assigned a particular key, and they are grouped together and they are stored like that. So that is nothing but key value. So a data has a key and a particular value. If you want particular data, you can search it the particular key. Then we have document. Data stored as like JSON files, they are document itself, right? Inside collections. Then different documents in same collections can have different fields. We discussed this in the previous classes, right? Where a user one will have name and email. The same another user will have name and phone number. Column family store. So this is document store. This is column family store. In column family store, stores all data column wise. Good for specific white tables. So it stores a particular. First, this column I'll store. Once I finish this column, then I'll go to second column. So the way we are doing right now. So we are explaining this, then this is a very practical real-time example. Yeah. Then we have graph database. So in this, the data is stored as nodes and edges. You know that this, right? Graph tree and all. You make the circle and all, and then you attach the lines. So it's all like that, and it's great for relationships if you have to relate a family member or something. So this also in your aptitude questions, such type of graphs will be asked. Let us say example for key value pairs. You have Dynamo style systems. These are just actual system names. For document store, you have MongoDB, CouchDB, Couchbase. Then for column family, you have like Cassandra, HBase, Hypertable, and for graph, we have Neo4j, HyperGraphDB. So if you just have doubts for that, you can see. So this is just a tree graph. Okay, sorry, graph. So this is directed graph. If I remove this arrow, it's non-directed, undirected, something like that. Okay. Then we will move to section 4.1.4. Why do we need NoSQL? So I have written 5 points over there. Scale out architecture. So in the sense, what, add more machines instead of buying one huge box. Okay. That is not how scale also, you're just expanding. Okay, instead of buying one whole thing, you can expand it. No need to buy a new house if you are having shortage of rooms. Just expand it, break one part and just construct over there like that. Then handles large volume of structured plus semi-structured plus unstructured data. So this is what it handles, the large volume of completely any volume of data. Dynamic schema, app can change no fields without costly alter table. So that dynamic schema, so in sense, changes in schema, so dynamic, so whenever it is required it will happen. Auto sharding, data automatically spreads across many servers. So sharding, say the main thing about sharding is you should also know that this sharding concept comes in Hadoop as well. Data shard is nothing but whenever data is taken as input or is it being processed or generated as output, so it automatically replicates a copy of it and stores it such that if one server or node fails, the another can use it as a backup. You have to remember that in auto sharding. See, auto sharding and replication both are related with each other. Replication is nothing but making multiple copies give high quality, high availability and fault tolerance. So both are related together. And if you talk about advantages, you see easy horizontal scaling. So horizontal scaling, adding multiple services to spoke previously. No predefined schema. So in this, you don't have to define the structure of the schema or a table. When and where you want, you can add and expand it. Cost effective, cheap nodes, less cost, relaxed consistency, and then the auto sharding and replication repeats here. For that, you can simply say that um, what did you say? High availability. Okay, high availability and fault tolerance. Sorry for the pause which I took over there. I had to explain in a smooth language, but still, anyways, sometimes happen. Okay, so if let me tell about relaxed consistency. It allows high availability and partition tolerance, eventual consistency. So in the sense, what in the cap theorem we have CAP, right? So it provides CAP and sometimes eventual in the sense, sometimes in some events it will also give us consistency. Okay, so a small thing, 1.6, what we miss with NoSQL is very, very, very small. So here, compared to RDBMS, typically NoSQL system lack joins and group by style complex queries for their or they are harder in the sense what. So in normal RDBMS, you can perform the joint query and all, in which you can join two tables etc like that. But here it's a little bit harder. It's not possible. It's like that. It's complex to do it. Do not fully support multi-law and multi-document ACID transaction. So it, as we saw here, right, it does not fully support the ACID properties. It fully in the sense what, not complete, but some part it does, but it follows the CAP theorem. Then it does not use standard SQL, so integration with SQL based tools is harder. So this is the thing what we miss with NoSQL. Only 3 points, right? What? No queries like join or group by, and does not support multi-row, multi-document ACID transaction, and does not use standard SQL, so it's difficult to integrate with that. NoSQL vendors. This is very simple. What are the NoSQL vendors? So okay, I'll explain the what to say using industrial, but first we'll see the NoSQL vendors. So it is Amazon, Facebook, Google. So I just said FB over here and Google like that. So just don't take it as a mistake. I just written the short term so that I can fill it in the gap. So you have, for example, for Amazon is DynamoDB, Facebook is Cassandra, and Google is Bigtable. These powers sites like LinkedIn, Netflix, Twitter, eBay, Adobe products, etc. Okay, SQL versus okay, so use of NoSQL in industry. So same things are repeating in the this section. Key value pair, document, column oriented, graph based. In key value, what do I return? Shopping carts, session storage, user profile, caches. See, shopping, it's all a key value pairs. So each product has a a particular key. So and the value is nothing but the visual product, actual product like that. Document, real time analytics, logging content, and document management. Column oriented, analyzing huge web logs, sensor feeds, clickstreams, graph instance, all social networks, recommendations engines, fraud detection. So basically, you have to remember the main 4 points. It is which I have listed: the key value, document, column oriented, and graph based. Remaining, you don't have to worry much about that. Then we have to talk about SQL versus NoSQL, high level. Okay, so here we have completed this part here, and the only part left is 4.1.9, 10, 11. This is 9, 10, 11. These three are muchly related to each other, because here we'll talk about SQL versus NoSQL. And the last part, same thing, we'll compare with new SQL. And this, the left off part, is nothing but introduction to new SQL, what and why. Okay, so we'll just look into that, SQL versus NoSQL. SQL is nothing but relational RDBMS, where you write queries, fixed schemas, all the things which we was a problem, and to correct it we have introduced this NoSQL. So here, relational tables, fixed schemas, vertical scalable, strong strong transactions, ACID transactions. In NoSQL you don't have any. It's not relational. It's not relational. It's not relational, because RDBMS says relational. Here we are opposite, non-relational. Dynamic schema, fixed schema, dynamic schema. You can see this better in comparison. Horizontally scalable, and follows capture and often eventual consistency. In the sense, what APs will be there always. APs, what availability and partition tolerance will be there, but sometimes also consistency eventually. Best for very large hierarchical or semi-structured unstructured data. Then we have new SQL. What is new SQL? It is a nested NoSQL, like scalability plus SQL, like ACID plus relational model. I know it's confusing. So no new SQL nothing but nested NoSQL. So nested NoSQL, along with standard SQL, like ACIDs plus relational model. So it gives us NoSQL like scalability, and SQL like ACID transaction. Okay, NoSQL like, I'll write what is the scalability, and SQL like ACID transactions. So see, NoSQL lack this ACID transactions, right? So instead of now, and SQL has scalability, wherever like flexible schema and all, addition of fields and all, nodes and all. So we are combining this both. Also relational model. So both of them plus relational. Sorry for the handwriting. So now see, all are this nested like together. So that's why it's called new SQL. So it has a relational model and SQL interface, full ACID transactions. Okay, so it has the advantages and benefits of both new SQL and just SQL. So it shared nothing scale out architecture, in the sense, what it has its own CPU, it has its own memory, it has its own operating system. It does not share anything to anyone. If any system fails, only that part will be affected and won't affect the remaining system. Non-blocking concurrency, so reads and writes don't block each other. In the sense, what, so if you have to read the data, the write will be blocked, right? If you have to write, the read will be blocked, so it won't block each other. It will be happening in the backend and automatically updates, and you can use it flawlessly. Aram se, very good. 4.11, the last thing is the comparison of SQL versus NoSQL versus new SQL. So here you can understand this from notes more easily. You just have to talk about ACID transaction. Just type S, no, like that. So does SQL support ACID transaction? Yes or no? NoSQL? Yes or no? No, it doesn't support. But new SQL, it does. OLTP, that is nothing but online transaction platform. So usually NoSQL does not use OLTP, but SQL and NoSQL uses. If SQL is yes, then automatically a new SQL becomes S, because it comes from it, right? Like inherited, something like that. Then you have schema rigidity. SQL is rigid, NoSQL is flexible. And when you talk about new SQL, it's like medium. It's easy to understand like that, right? Just a second. Then you have data format flexibility, like SQL has low data format flexibility, the format of the data. But if you talk about NoSQL, it has scale out. We spoke about it. Scale out whenever required. You will just add a new part instead of buying the whole block. Then in NewSQL, it's also same as NoSQL. Same scale out you have read. Then scalability. SQL is scale up, NoSQL is scale out, NewSQL is also scale out. Then distributed computing, all three can support it, but style differs. So we spoke about 6 things when you compare this. You just have to write the table. Here you are writing the features. Okay, so here you will be putting those three SQL thing, no, new and all, and then just type s no s no s no. And if you want, instead of writing these features, remove it and write it supports ACID transaction, so you can write big sentences and it will take the whole page. So this was about NoSQL. I know I did not show myself much in this screen and explain to you, but anyways, I have done what I can do to explain you all and and make you understand. I hope you understood. If you did not understand anything, you can let me know. At the same time, just like the video and subscribe. Like it doesn't pain to do it. So anyways, see you in the next video.